Look at the pictures of these jewelry. What is the common metal used to make these jewelry? Yes, they're all made from gold. Why do they have different colors even though they are made from gold? This is because of the various combinations of metals and gold that has created different colors of gold. Did you know that there are yellow gold, rose gold, white gold, and green gold? Guess the compositions of the gold based on their colors, and let us do this activity by drag and drop the pictures and the description in the correct frames. These golds are examples of alloys. Do you know what alloys are?
Look at the boxes to find out more about alloys. What happens when metals combine with other metals? Click on each of the boxes A, B, C, and D to see how alloys are being formed. Pure solid copper is melted. Zinc is added and mixed with the liquid copper. The alloy form is brass. Pure solid iron is melted. Carbon is added and mixed with the liquid iron. The alloy form is steel. Pure solid tin is melted. Copper and antimony are added and mixed with the liquid tin. The alloy form is pewter. Pure solid tin is melted. Lead is added and mixed with the liquid tin. The alloy form is solder. An alloy is a mixture of two or more metals or a mixture of a metal and a non-metal. Note that when an alloy is formed, the metal combines with another element in a small quantity to ensure the metal characteristic is maintained. Alloys have different properties from its pure metal. Click on the box to find out the compositions and properties for each type of alloys. Brass is harder and stronger than copper, so it is suitable for household ware and musical instruments. Bronze is more resistant to corrosion compared to copper, and it is used to make ship propellers. Steel is stronger than iron, so steel is used to make the framework of bridges and buildings. Solder has a lower melting point than tin. It is useful when soldering or fusing two wires in an electric circuit together. Pewter is a bright and shiny metal that looks like silver but does not tarnish easily. Duralumin is very light and strong compared to aluminium. It is used to make aircraft. From the properties shown, can you name the main purposes of making alloys? Yes, we make alloys to change the physical properties of the metal to suit our needs. These include increase the hardness of metals, prevent the corrosion of metals, improve the beauty and luster of metals. We have studied the properties of some alloys. Do you realize that we use items made of alloys according to our needs and purposes? Which alloys are these items made of? The musical instrument trumpet is made of brass. Statues are usually made of bronze. The body of the bullet train is made of duralumin. Decorative ornaments are made of pewter. Railway tracks are made of steel. And solder is used to bind wires of an electrical circuit. Do you know why these items are made of these alloys? Drag and drop the properties of the alloy to suit the purpose of the item. Each metal is made up of atoms of the same type and size. Metals are ductile and malleable. Let's find out more about these properties. Click on the Box A button. The ductile property of a metal is the ability of the layers of atoms to slide over each other when a force is applied. As a result, metals can be made into wires. Metals are also malleable. Click on the Box B button. Although the atoms are arranged in an orderly manner, there are still spaces in between the atoms. These spaces allow movements of atoms when a force is applied. A metal is said to be malleable when the positions of the atoms can be changed by applying a force. As a result, metals can be shaped. These two properties of metal enable it to be hammered into different shapes or pulled into a wire. We have seen that the atoms in pure metal are of the same size because the metal is made up of the same types of atoms. The closely packed and orderly arrangement of these atoms give the metal its ductility and malleability properties. What happens when we add some bigger sized atoms to this metal? Click on the Alloy 1 button to find out. Click on the Pull Me button to stretch it. Click on the Knock Me button to hit it with a hammer. What can you observe from the two animations? Why does the metal ductility and malleability decrease when some bigger sized atoms are added? Would it give a similar effect if we add some smaller sized atoms to this metal? Click on the Alloy 2 button to find out. Click on the Pull Me buttons to stretch it. Click on the Knock Me button to hit it with a hammer. What can you observe? Does it give a similar effect to Alloy 1? Why? From the observations in Alloy 1 and Alloy 2, we can see that the foreign atoms, be it big or small, occupy the spaces in between the metal atoms. The layers of the atoms cannot slide over each other so easily when a force is applied. They get jammed in place. Thus, we can conclude that when two or more metals combine together, the alloy formed is stronger and harder than the original metal. We have studied the properties of pure metals and alloys. Let us compare the differences in properties between them. Drag and drop the appropriate properties for the metals and alloys into Table 1.
In this lesson, you have learned that an alloy is a material formed from a mixture of metal and other elements which may be metals or non-metals. The main purposes of making an alloy are to increase the strength and hardness of the metal, increase the resistance to corrosion, improve the appearance of the metal. There are various types of alloys that are used in our daily life depending on their properties and composition. Some examples are shown in the table. Metals contain atoms of the same type and size. The atoms are packed closely in an orderly manner. The layers of atoms can easily slide over each other, making metals ductile and malleable. When two or more metals combine together, the alloy formed is stronger and harder than the original metal. The new atoms in the alloy, be it big or small, occupy the spaces in between the metal atoms. The layers of the atoms cannot slide over each other so easily when a force is applied.